right, apologies, guys. This is grade 9 maths, and I'm very sorry that I am late because we were supposed to have started at 7 a.m. Grade 9 maths. So let's please share the live with the relevant people that are doing grade 9 mathematics this year so that they can actually be up to speed with what we are doing here on this platform. Also, secondly, if Alright, so like I said, this is a grade 9 maths session, calling on all grade 9s. Grade 9, if you're doing mathematics grade 9, you are welcome into the session. Please share the live. We will be starting in at 7:30. At 8:30, we will follow that up with grade 10. So grade 9 maths, all grade 9 maths learners who may be around, who are doing grade 9 here in 2025 term 1, inviting all grade 9 learners, who are doing mathematics. Please double tap on the screen, share the live with all and any grade 9 learner that you know. Grade 9. Please share the live with all grade 9s, any grade 9. Alright, so I guess in the absence of other learners joining, I will start the session, and then hopefully those who are in grade 9 who have not joined the session, they must remember that on the YouTube channel, which the link you can find in my bio, the YouTube channel that is called Maths is a Game. The lesson for today that I will have covered now is on the YouTube channel, so people are more than welcome to go on there and they can watch the sessions that have been done already in December, and also the session that are currently happening and will happen in the future. They are all there. Alright. It does take time for me sometimes to upload the sessions, but when I eventually do, they get uploaded and people can have the opportunity of checking them out and being able to utilize them for themselves. So yeah, let us begin. Today we are still on the subject of whole numbers for grade 9. Now, we've done many other things under whole numbers, but today we'll be specifically looking at something that we refer to as ratio. So what is ratio? In simple terms, ratio is the comparison of two or more quantities of the same type. So I repeat, grade 9. This is grade 9, people. Those who are joining in, it's grade 9. Alright, grade 9 mathematics, which will be followed by grade 10 later on. Let's say at 8:30, 8:45. Alright, after this session, we'll do grade 10. So we are doing grade 9 this morning. So please do share the live with those that you know that are in grade 9 currently. You can share the live with them so that they can join. They can be part of the early preparation that we are doing already for our grades for mathematics. Also, if you are joining for the first time and maybe you are like, okay, I see that you're doing ratio, but what about all the other topics for the term? The lessons that I conduct here on this platform are done according to the ATP for the year. So I've already done some of the pre-lessons that are leading up to the lesson that I'm doing. So if you want to check those out, please do go to the YouTube channel. It's also called Maths is a Game. The link is found on my bio. And you can actually go there and watch the previous live sessions that we've done. They are lengthy, of course, because it takes sometimes 1 hour, or even more than 1 hour, sometimes 2 hours to complete a session. So you can watch those and you can watch them to your heart's content. Stop and start. Of course, there's like now, I'm busy giving some information and I'm not really teaching the content. So there are moments like that in the live. So please move forward to where I start teaching so that you can be able to learn the content. All right. Yes. Okay, let's continue. So Ratio, what is ratio? Ratio is the comparison of two or more quantities of the what? Of the same type. That is what a ratio is. Okay. So it's important to understand what a ratio is. Now, it is represented in the following manner. When we talk about ratio, we represent it in the following manner. So let me just give you an example. 10 is to 8. This is what we call a ratio. There's a number here, which is a whole number, and then there's a number here, which is a whole number. So since the ratio is falling under whole numbers, we have a priority or a responsibility to ensure that the ratios that we have, the ratio when it is represented, has both whole numbers for the quantities that are being compared. 10 and 8 are numbers that are the same type, and we are comparing the two. 10 is to 8. That's why we say a ratio is a comparison of two or more quantities of the what? Of the same type. So we have a responsibility firstly of making sure that these numbers are whole numbers. 2, they need to be numbers that are of the same type. In other words, if it's 10 this side, then it must be, if it's 10 without a unit this side, then it must be 8 without a unit this side. I hope that makes sense, right? So that is our responsibility whenever we have a ratio. Now something else to note is that this 10 is to 8 can be written as 10 over 8. So in other words, another way to represent a ratio is representing it as a what? As a fraction, especially if we are comparing what? Two numbers. If we are comparing two numbers of the same type, we can also write or represent the ratio as a fraction. Okay. Now maybe that might bring light to something else that you may have actually noted. If you note, there's this thing that we call a rational number. And a rational number, if you look at the word itself, the word rational has the word in it ratio. And remember, whenever we define what a rational number is, we usually say, what is a rational number? A number that can be written. And I just want to pass through this. This is not part of the lesson, but this is something to note. A number that can be written in the form A over B, or where A and B are integers, and where B can never be 0. So if you think about it, the form in which a rational number is represented, it is represented as a fraction, which fraction we refer to as another way of representing a ratio. Okay, I hope you guys understand me. I hope you are hearing me. I hope you are hearing me very well. So I repeat, a ratio is the comparison of two or more quantities of the what? Same type. The next thing, it is represented in the following manner. Here's the manner in which a ratio is represented. A whole number, and then this dot and this dot here, alright, is basically the notation that we utilize to represent ratio. And then there's another whole number this side. So there's a whole number on one side, a whole number on the other side. And remember, like I said, it could be how many quantities? It could be two or more, but in this case, we just have two. A whole number on the left, a whole number on the right. So a responsibility we have whenever we represent a ratio is making sure that we have whole numbers on either side. Then 2. The second thing, these numbers need to be of the same type. What do we mean they need to be of the same type? We mean that they need to have the same unit. They can't have different unit. Because the minute we are comparing two quantities that have different units, we are no longer talking about a ratio, but we are talking about something else. And we will look at that thing later on. But for now, we are specifically looking at the ratio. So for those who are joining in, this is grade 9 mathematics. Please continue to tap on the screen. Share the live with those who you know will be doing maths in grade 9 term 1, so that they can benefit from this session. All right, and those who might be joining in who are like wondering what in the world is happening maths in January, listen people, schools have not started and all of those things. Please note that we are doing this early so that we can actually make sure that our marks for this year are brilliant. We want nothing less than a level 5, and our goal is to level up so that we get level 7. It's clean. So early preparation ensures that, and if we do our work, we'll be fine. So I repeat, for those who are joining in, please, you can subscribe to the YouTube channel. It's called Maths is a Game. You can find the link in my bio, and you can find the lessons that we have done previously so far, term 1. We've done lessons already in December, and those learners that have been joining in have been benefiting from that. So please go and subscribe there and actually go and watch the videos that we've done so far for grade 9. If you have a grade 9 learner, then this is the place for you. If you have a grade 10 learner, we'll be having a session after this session. After this session, we'll be having grade 10. If you have a grade 11 learner, a grade 11 child in your home, 9 p.m. is the time that we do grade 11 sessions. And then if you have a grade 12 learner, the sessions are done at 10:30 at night. So 9 o'clock, 9 p.m. at night is grade 11 maths. 10 p.m., 10:30 at night, it's grade 12. Okay, and the sessions that have been done previously are uploaded on my YouTube channel. You can watch them there. The Tabo grade 8, we have not yet actually gotten a flow for grade 8, because I don't know, when I have a grade 8 session, few people join the session even if I announce it. So far I'm asking all grade 8 learners and parents that are interested in me having sessions for grade 8 to please inbox me or send me a message so that I can get an indication that there are people interested, and then I can have a scheduled session for grade 8s as well. So far I did one session, but it was poorly attended, and even the lesson has been uploaded on my YouTube channel for the grade 8 learners, the first lesson, but I have not since continued after that. Okay, so please just inbox me or send me a message privately so that I can get an indication of those who are interested in doing grade 8 maths. All right, now let's get back to my lesson. All right, the information was a lot. Ratio, like I said, for grade 9s is the comparison. This is a topic that's also done in grade 8, because much of the grade 8 and the grade 9 lessons are similar. All right, so ratio is the comparison of two or more quantities, like I said, of the what? Of the same type. It is represented in the following manner. A whole number, which is one quantity, with this double dot, which is vertically written underneath each other, and then 8, which is another quantity. These are both what? Whole numbers. All right, because we remember what whole numbers are, Mosne. Whole numbers are numbers that start at 0, they go up by 1 up until infinity. So these numbers are basically numbers that are qualifying as whole numbers. This is a ratio. A fraction is also another way in which we can represent a ratio of two quantities. Take note, it is another way of representing a ratio of two quantities. In the order, 10 in the numerator, 8 in the denominator, from left to right, top to bottom. If you remember, what is a rational number when we define a rational number? A rational number is a number that can be written in the form A over B. So this word rational has the word ratio in it, and that was something I wanted to point out. So that is why a rational number can be represented in this form, because it has the word ratio, which is basically the root word that basically makes up this word rational. Okay, now let's continue. So for the purpose of calculations, we are going to look. So when we look at calculations for rational numbers, for ratios, we are going to look at 3 different types of questions. So hopefully today we'll be able to cover those 3 different types of questions. So for calculations for ratios, we are going to look at 3 types of questions that can be asked where ratio is concerned. The first one is what we refer to as simplifying ratio. Simplifying ratio. So what do we mean by simplifying ratio? So let's take a minute and a moment and write down a ratio. So example 1. If they say simplify 10 is to 8, how do we go about simplifying 10 is to 8? So as grade 9 learners coming from grade 8, you guys should know how we go about simplifying a ratio, because you did this last year. It's not like you are doing this for the first time. It's just that in grade 9, I want you to note that you do this very same thing again. All right. So Lesego is one of my brilliant learners here on this platform, who is very quick on the typing in the screen and is very alert and aware whenever we're doing lessons. So Lesego has already said dividing both sides by 2. Dividing both of the numbers by 2. Now let's note here. So step number 1 when we do this question is we need to first check, do we have whole numbers for the quantities of our ratio, and are these quantities of the same type? That's what we check first. So yes, 10 and 8 are what? Are whole numbers. That's the first thing. If 10 and 8 are whole numbers, we can say check. 2, are these quantities of the same type? In other words, do they have the same unit? So both of them don't have a unit, which means they are of the same type. So if they are of the same type, we can say check. Then, now, because we've established that these numbers are both whole numbers, 1, meaning they are both whole numbers, check. 2, both of these numbers are of the same type, meaning they have the same unit, they are both unitless. Then it means we can go ahead and do the following. Find the what? The highest common factor between these numbers. Yes, this is grade 9. This is grade 9. Find the highest common factor between the numbers. Now at this point, because in the previous lessons we've done how to find the HCF and all of those things, you should be able to find the highest common factor if you don't know it. But if you know the highest common factor, then you can find the highest common factor between the numbers and what? And divide both numbers by both numbers of the ratio. Okay? Both numbers of the ratio by the highest common factor. Are we together? If you are doing if you are going to be going to grade 9 this year, this is the lesson for you. Right? So find the highest common factor between the numbers and divide both of those numbers of the ratio by the highest common factor. So what Lesego said is correct. We take 10 and 8. We found the highest common factor. The highest common factor, first and foremost, is what? Is 2. The number, the biggest number or the greatest number that goes into 10 and 8 is 2. And why do we say it's the highest common factor? It's because 2 goes into 10 and 8 and leaves no remainder, and it is the highest number. Please, people, we don't just go for a factor, but we choose the highest common factor. And how we find it, we have various methods to find the highest common factor. If you have forgotten what those methods are, please go to my videos that I've done for the previous lesson, because we looked at how to find the highest common factor extensively in those videos. All right, on my YouTube channel, Maths is a Game. The lessons are there. So then we divide by 2. So we both divide 10 and 8 by 2 because they are the highest common factor. What's 10 divided by 2? Katlego, you're not late for this particular lesson or live session because I just began it. 10 divided by 2 is what? Is 5. 8 divided by 2 is what? It's 4. So I have just what? I have just simplified the ratio 10 is to 8. Alright, and the answer is 5 is to 4. Okay, so that is what we do. That is what we do whenever we are simplifying a ratio. Alright, so just once again, remember I said when we simplify a ratio, first we need to check a few things about the ratio. First check, do we have whole numbers for both of the quantities that are represented in the ratio? Yes, we do. Check. 2, are these quantities of the same type? In other words, do they have the same unit? 10 has no unit, 8 has no unit, which means they are of the same type. Check. Then when we have established that, we go on and find the highest common factor between the numbers. So we find the highest common factor, which in this case is 2, because the highest common factor of 10 and 8 is what? It's 2. Then lastly, we take that highest common factor, we divide both the numbers of the ratio by the highest common factor, which we've just done now. We took 10, the first number in our ratio, we divided by 2. We took 8, the second number in our ratio, we divided by 2. And please, people, remember that notation for ratio is still there. In our final answer, 10 divided by 2 is 5, 8 divided by 2 is 4. So this is the simplified form of the ratio 10 is to 8. Okay? Are we together? I hope we are. Let's look at another example. Maybe this time round, the example that we are going to look at may be slightly bigger numbers that we have represented in the particular ratio. And look at this ratio. Okay, it's 350 is to 200 is to 100. If you go back to my definition, I said the ratio is the comparison of two or more quantities. So now in this ratio, we don't have two quantities. We have how many quantities? 1, 2, 3. But the comparison of these two or more quantities are of the what? They are of the same type. In other words, they need to have the same unit, right? That's what we mean that they are of the same type. Okay, so let's go back here. Remember, we need to do what with this? We need to simplify, because that's the first type of question we get asked for ratio. So step number 1, we need to check that 350, 200, and 100 are all what? Whole numbers. Are they all whole numbers? Yes, they are, because we remember what our definition of whole numbers is. So are they all whole numbers? Yes, they are. So check. Okay, check. They hate shady. I think the name itself tells you, right? But we love you in the platform. Take care of yourself. Have a great life. And I hope this year is flowing with blessings and love for you. May you receive love in your life. All right. May you receive love, my friend. 350 is to 200 is to 100. Okay. So whole numbers, we said they are whole numbers. 2. Are they having the same unit? Meaning, are they of the same type? 350, 200, and 100. Are they of the same type? Check, they are. They are of the same type. So if they are all whole numbers. 2, they are having the same unit, meaning they are of the same type. They are all unitless, most. You can see most. Then 3, what do? We must find the highest common factor. And once again, like I said, finding the highest common factor is something we should all be able to do. So what is the highest common factor of 350, 200, and 100? The biggest number that goes into 350, 200, and 100. We need to find what is that biggest number that goes into all of these numbers. Okay, So Sabelo has indicated in the comment section that it's 50, even Steamroll is doing the same. Right, so let's go. These people, they are saying the number is 50, and the question is the highest common factor between 350, 200, and 100. Is it really 50? Yes, it is, guys. That is the highest common factor. So the highest common factor between these three numbers is 50. And if we have forgotten how to find the highest common factor for numbers, what's beautiful is that if we have that Casio calculator that is white, the white Casio calculator, that one, it gives you the factors, the highest common factor for numbers that you have. If you have the Casio calculator like I do, then of course you can use the prime factorization method to basically find the highest common factor between three numbers, all right? And like I said, if you want to know how that is done, please go to my YouTube channel, Maths is a Game, and watch the last lesson that I did on highest common factor and LCM, because I explained the method of finding the highest common factor. So yes, the highest common factor is 50. Then what do we do with that highest common factor? We divide all numbers in the ratio by the highest common factor. So let's do that. So 350 we divide by 50, 200 we divide by 50, 100 we divide by 50. And then after we do that, once we wrote down the highest common factor is 50, then we actually divide all three numbers in our ratio by what? By 50. What is 50? How many times does 50 go into 350? 7 times. You can just utilize your calculator even. 50 goes into 200 how many times? 4 times. And then lastly, 50 goes into 100 how many times? 2 times. So we have a ratio of 7 is to 4 is to 2. This is basically, when we read this, we say 7 is 2, 4 is 2, 2. All right? That's basically how we read it. 7 is to 4 is to 2. Right? Okay. Okay, I hope that's fine. We are good. Menier can continue. All right. See, applying the same method as we were going along. Right. Let's look at this example. Something a little bit more feisty, a little bit more exciting. All right. So hopefully you guys can see what we have there on the screen. And now we need to simplify. And if you look at this ratio, okay, we have 60 minutes is to 1.5 hours. Now, if we look at this ratio, okay, we still are going to follow the same method. We look at the ratio, we ask ourselves the question, 1, do we have a whole number here? Do we have a whole number there? And guys, I'm sure you can see that. Sabelo, I see you, just hold your horses. I know you kind of know what you need to do, all right? But just hold your horses, okay? And I love the fact that you are answering the question nicely, which is good. I'm happy it means you are on top of your game, all right? And I commend you for that. Naxi, I guess it's also depression when parents get reports where the level for maths for the learners is either level 1, 2, 3, or 4. Those are depressive levels for any learner to get if they are doing mathematics. What we're trying to do here by having maths being done early in this live session is to sort of cultivate in the heart of the learners their ability early, so that when they get to school, it's like they're doing revision and it's easier to do the maths, so they can get level 5, 6, and 7. Parents will not be depressed. Learners won't be depressed at the end of the year. They'll be happy, and the maths confidence can be restored. So that is basically, hopefully, what we're trying to run away from. I'm glad that I'm reminding you of that. Okay, and Roland, thank you so much. I really appreciate that. Yeah. So like I said, 60 minutes is to 1.5 hours. Guys, so first thing, what we need to do is we need to make sure that we have a, this is grade 9 at the moment, Naxi. We're actually doing all grades except grade 8 so far. So it's grade 9. I usually typically do it at 7 a.m. in the morning. Grade 9, since schools haven't opened, I'm doing it at 7 a.m. in the morning. Then grade 10 follows thereafter. After I'm done with the grade 9 lesson, I do grade 10, which typically is at 8:30. Then grade 11 is done in the night. At night, we do grade 11, 9 p.m. And then grade 12 at 10:30 at night. All right. So we've been doing these sessions since December. The live lessons and the sessions that have been done so far are uploaded onto my YouTube channel. It's called Maths is a Game. You can go on there, you can subscribe, and then you can actually watch the previous sessions that we have done. Okay, so, I still going to grade 6, that's fine. Like, I still young, it's fine. But yeah, like I said, actually, we're just trying to help out, and there's just a few things that, I'm trying to accomplish by doing this, and freely so, not making learners pay, but freely so, trying to really help out. I'm just trying to do my bit, So 60 minutes is to 1.5 hours. Let's get back to the lesson. So 60 minutes and 1.5 hours. We need to check first our ratio. Do we have whole numbers for our quantities in our ratio? So you can clearly see 60 is a whole number. All right, and minutes is the unit that denotes the 60. 1.5 hours, this is not a whole number, guys. This is a mixed number. So somehow we need to get this mixed number to become a whole number. Plus, look at the quantities, guys. Look at the units. This is minutes, this is hours. These are different what? Units. They are not of the same type. So what we are going to do, one is going to influence the other. In other words, if 60 is already a whole number, it means we have arrived here. But here, this side, 1.5 hours, we have not arrived. So 60 minutes is going to convince 1.5 hour to change, one, firstly, its unit, two, to change its numerical value. In other words, this 1.5, we need to change it to a whole number. Are you with me? Right? So, step number 1. Speaking Chinese, no problem, like no problem. Are you killing me? So whole number. So first and foremost, are these both whole numbers? No. So if they are not whole numbers, then it means we need to undergo a process of conversion. Convert these non-whole numbers. The ones that are not whole numbers, we need to convert them to become what? Whole numbers. So let's look at the conversion. When we are talking about minutes, surely all of us know that 60 minutes, obviously 60 minutes, that's a whole number. So it's fine. We are good here. 60 minutes is fine, Shem. Is 2. Can we convert our hours to minutes? How many minutes are there in 1 hour? That's what we need to ask ourselves. How many minutes do we have in 1 hour? Hopefully all of us, we know hour, minutes, seconds. This is something that I like doing with my learners, this conversion scale. So from an hour to a minute, we times by 60. If we want to convert an hour to a minute, we times by 60. Why do we times by 60? Guys, what we know is that how many minutes are there in 1 hour? There are 60 minutes. There are 60 minutes in an hour. Then if we want to convert minutes to seconds, we also times by what? By 60. Because how many seconds are there in 1 minute? We know there are 60 seconds. Okay? Then, what I also like doing, so I write the arrow here and I write the arrow here. Then obviously, then that's true vice versa. That if we want to convert seconds back to minutes, we divide by 60. And then if we want to convert minutes to hours, we divide by 60. Okay, So this is grade 9, guys, all right? So we have 60 minutes, which is fine. This is a whole number. We can accept the unit. Now, this whole number with its unit is going to convince 1.5 to change its number to a whole number. So how many minutes are there in 1.5 hour? So we can break this down. 1.5 hour means 1 hour and what? And 30 minutes. That's what it means. 1.5 hours. 1.5 hours means 1 hour plus a 30 minutes. Are you with me? How many minutes are there in an hour? There are 60 minutes. Plus what? Plus 30 minutes. So in total, how many minutes is 1.5 hour? It is 90 minutes. So I repeat again. 1.5 hours. What does that mean? It means 1 hour plus a half means 30 minutes, because a half of an hour, all right, in an hour we know there's 60 minutes. What is half of 60? It is 30. Are you with me? Then 1 hour is 60 minutes plus what? Plus this 30 minutes. So in total, what is 1.5 hours as a whole number? It is 90 minutes. All right. And like I said, this conversion scale may be helpful if we have it written down somewhere so that we can use it whenever the occasion arises. I mean, if our learners know time very well, then they will know that in an hour, there are how many minutes in an hour? There are 60 minutes. That's why we multiply hours by 60 to get minutes. In a second, in a minute, how many seconds? There are 60 seconds. So that's why we times a minute by 60 to get how many seconds there are. Then vice versa, whenever we want to find convert seconds to minutes, we divide by 60. Convert minutes to hours, we divide by 60. So guys, that is very critical. So our 1.5 hours can finally be written as a what? As a whole number. And look as well, it's a whole number. 60 and 90, they are whole numbers. And look at the units. We have minutes, we have minutes. Now our numbers in the ratio are of the same type. In other words, they have the same unit. So we've done the conversion. We can now officially say we have whole numbers for both quantities in our ratio. 2, the same unit, so that the ratios are of the same type. Are they now of the same type? Yes, they are. Yes, they are, guys. This is minutes, this is minutes. They are of the same type. We officially now have a standard ratio, because what did we say a ratio is by definition? The comparison of 2 or more quantities of the what? Of the same type. They have the same what? The same unit. We have just converted 1.5 hours to be of the same unit as well, with whole numbers represented for each what? For each quantity of our ratio. So step number 1, done and dusted. Please, people, whenever we simplify ratios, we always need to first check, are these both whole numbers? If not, we need to convert them to be such using appropriate and correct methods. All right, and then units, are they of the same unit? This is minutes, this is hours. So we have to then convert this one that is not having a whole number to become the same unit as what we have on the left quantity. Are you with me? Now we have the same quantity. What is the next step that follows? The minute we have the ratio and it is of the same type, meaning it has the same unit and it's both whole numbers, we can now move on to the next step, which is we need to find the what? Find the highest common factor. How do we find the highest common factor between 60 and 90? I've covered how to find the highest common factor between numbers extensively in the previous live session that I did. You can go to my YouTube channel, Maths is a Game, and you can actually go and click on the thumbnail for the grade 9 lesson that I did previously, where I covered what highest common factor and lowest common multiple are and how to find it. Then, in Those who know what is the highest common factor between 60 and 90, I'm going to allow people to comment in the comment section and tell me what the highest common factor between 60 and 90 are. Okay, Trompo, thank you so much. You said 30. Let's just wait to see if others are on the same boat as you. Tebucho says 30 as well. Lesejo also says 30. All right, and I just need one more person to probably tell me the real answer, not this false answer that people are giving me in the comment section. Who knows the real answer? Pano says 30 as well. Owami says 30. Reno says 90. Okay. Now, when I said false answer, I was just kidding. I wanted to see if people will actually try and find something else. Now, someone who is sure about their mathematics will not write something that is off the rails. Okay, so when I said false answer, that was just a trick to check if people will actually stick to what they know is right and true. Okay, so unfortunately, Remo, if you say the highest common factor is 90, my question is, does 90 go into 60? No, it doesn't. Does 90 fit into 60 and leave no remainder? Definitely not. Just vibes, you said it's 3. If I use 3, I am going to divide 60 by 3, but the thing is, it will not simplify my ratio completely, which means I'm going to have to find another number and divide more and more and more. Okay, I think if you do that, then I guess you'd have to go about that process and it will take a long time. The highest common factor is that highest number that fits into 60 and leaves no remainder, and fits into 90 and leaves no remainder, but it simplifies the numbers that we don't have to find another number to divide the numbers that we have found by. So yes, all the people that said 30, you guys are angels from heaven. Are you really though? Are you really angels from heaven? Is that really though the highest common factor? Okay, yes it is. So what do? We can just forget for now about the unit because we know it's of the same type. Okay, and then we can take our 60, the whole number, divide by 30, take our 90, divide by 30, because that's what we do. After we find the highest common factor, we divide each whole number by 30. Stana girl, haibo isikolo sesivulile njalo. Amen. Stana girl. Schools have opened for my amazing maths gamers. Tina, we want to get romantic marks for this year. We don't want to play around. So if you want to join the revolution and you are doing high school maths, then you are welcome, Stana girl. Don't be stunned. Don't stun others with other things. Stun them with your maths. 30 into 60 goes 2 times. 30 into 90, 30, 60, 90 goes into 90 3 times. Our ratio has been simplified. Nati, you are spot on. You are spot on. Guys, the explanation may have been long, but hopefully it resonates. You see, but oh, hey, ilula lendo. It's weak. There's really nothing in this thing, right? So our simplified ratio is 2:3. Thank you so much, Pano, for the rose. I really appreciate it. Okay, let's look at another example. Example 4. Okay. Okay. These examples are all different and unique in their own way. And the reason why I'm doing that is so that I can expose you to sort of like the different scenario types that you can get when you are asked to simplify a ratio. We first did a simple one where we were given the whole numbers. No problem, we just find the highest common factor, we simplify. And then I gave you another ratio where the numbers were a bit bigger. Okay? Alright? And we did the same thing. The whole numbers are there, no problem. And then we just came from an example where we have a whole number, but then we need to convert one of the quantities in our ratio and then simplify accordingly. Now look at this one. Grade 9. Grade 9, this is grade 9. but also applicable to grade 8 because grade 8 do the same thing. They do the same thing. Grade 8 and grade 9 maths is so similar, it's not even funny. It's not even funny. And the syllabus is, there's repetitions there and there. So those who will continue with me in the journey for grade 9, I will note and I will single out the aspects which are the same for grade 8 and 9 and the aspects that are different. Okay, show me grade 8 lessons are not happening because when I go live for grade 8, attendance is poor. Okay, so we are doing so far grade 9, 10, 11 and 12. Okay, until I can sort of start getting people to really show commitment and attendance for grade 8 sessions in my live sessions, right? So and to get that, people can just send me a message privately and let me know that grade 8 we are interested. I don't do grade 7. I don't do primary people. I'm just doing high school. That is where the fight seems to be happening a lot, and I'm privileged to be in the high school setup, so that's why this. So let's look at this. 1 over 5 is to 2 1 over 5. First thing, whole numbers? Oh no, doesn't seem like these are whole numbers, all right? Doesn't seem like these are whole numbers. So we have mixed numbers. They are not whole numbers. So are these whole numbers? Nope. So that means we need to undergo a what? A conversion. We need to undergo a what? A conversion. And this conversion, whenever we have fractions, all right, for both our quantities, entails the following. So please take note, people, because we want to have a state where we have, at the end of the day, we want to have a state where we have whole numbers. So our mixed number, we are going to have to first do the following. We need to convert those mixed numbers into improper fractions. Now, everybody here should be able to know how to convert these mixed numbers into improper fraction. Hopefully, we all understand 1 over 5, for instance. If we want to convert 1 over 5 into an improper fraction, what we do is we take this 5, we multiply it by the whole number that's there, 5 times 1. Okay? And then we add it to the number at the top, 5 times 1. And then whatever we get there, we add to the number in the numerator. So 5 times 1 is 5, plus 1 gives us 6. Note that the answer we get, after we have multiplied 5 and 1, and then we add 1, we write that number in the numerator. It is 6. Then our denominator was 5, so it still stays as 5. So our conversion of mixed number to improper fraction of 1 over 5, remember it was 1 over 5, is actually equal to 6 over 5. So we are going to go and write 6 over 5 to now be in the place of 1 over 5. We do the same thing to 2 1 over 5. We convert that into an improper fraction. Okay, and I'm sure people in the comment section will rush to tell me what the answer is. Nati says 11 over 5. Tito bawo gena nati. Yeah, ngena nati in 2025 Tito bawo. Hey, so Nati, powerful name there. 5 times 2 is 10, plus 1 is 11 over 5. So you guys are spot on. 11 over 5. We are one step closer in our conversion. So from mixed number, we convert to improper fraction. We are not done because these are not mixed numbers. What? Yet. They are not mixed numbers yet. So what is the next step that we do after that? Alright, sorry people, there's just slightly something I want to change about this question because I want it to basically fit the description of what I want to do. So allow me to do the following. And I'm sorry about this, but I just want to change it slightly. So let's say the ratio was 1 over 5 is to 2 over 5. There's something I want to do, which is why I'm changing the question to this. All right, we were still on the right track. Just understand that the method is still what we are saying it is. All right, we changed these mixed numbers into improper fractions first. So 6 over 5 is still that, and yes, Nati, that 2 over 5, 5 times 2 is 10, 10 plus 2 is 12. So we have 12 over 5 in the numerator. Okay, so that's just a slight change. Okay, next, we are on our way. The conversion process is coming nicely. What is the next thing we do? The next thing we do is, I'm sure you guys can see that we have, in the denominator we have 5, in this denominator we have 5. So what we are going to do is we are going to multiply each fraction by the same denominator we see. Okay. So guys, check this out. Our denominator for both these ratios is 5 and 5. So what we are going to do is we are going to take the 6 over 5 and actually multiply by what? This is 5 in the denominator, so we're going to multiply by 5 over 1. We'll do the same thing for both 6 over 5 and 12 over 5. Usually what they do whenever they give us questions where there's fractions for both, where there's mixed numbers for both our ratios, they will make sure that the denominators of those mixed numbers are the same. Okay, so they will always sort of like make it such that the denominators are the same. All right, so don't worry about that. Okay, like I said, we multiply 6 over 5 by what? By 5 over 1. Okay, and then we multiply as well 12 over 5 by 5 over 1. That's what I mean by multiply by that denominator. But remember, when we multiply, it's like we are multiplying the whole fraction by 5. Remember, 5 as a fraction can be written as 5 over 1. Okay. Now, Nati says we get 30 over 5. When we simplify 30 over 5, we get what? What's 30 divided by 5? Remember, if you get 30 over 5, what is actually 30 over 5 equal to? 30 divided by 5 is equal to? No, use a 616. It's not. 30 divided by 5, guys, is equal to? Very good. 6. Thank you, guys. Thank you. Thank you. Thank you. Totally. Thank you. Rula, thank you. Peladi, thank you. Lesejo, thank you. Nati, thank you. And call me your savior, thank you. Then, 12 over 5 times 5. What does that give us? But hopefully you guys can see that. You remember when you guys did the mathematics with the simplification, okay? The 5 and the 5 would cancel out, remember? And then you would get 1 and 1 in that place, and then it would be 6 times 1, which gives you 6. 12 over 5 times 5 over 1. Okay, yes, it's 60 over 5, but when you simplify it, what's 60 divided by 5, guys? 12 times 5 is 60, 5 times 1 is 5, and then 60 divided by 5 gives us. All right, I see someone has written down the answer. Thank you, Lesejo. Thank you, Nati. Thank you, Becky. And thank you, Tlotli. We get 12. Definitely not 13. 5, Majab. 4. Thank you, Majab. Okay, so you fixed your answer there. Right? Okay. Like I said, they will always make sure that the denominators for your mixed number are the same. They won't give you a question where the denominators are not the same. In fact, they will do that so that they can make sure that you are able to simplify. So let's go. Let's proceed. Now that we have multiplied by 5, which we did, so we multiply by 5, we get 6 is to 12. Now we have what? We have whole numbers. You see, now we have whole numbers, guys. Now we have whole numbers. So with the whole numbers, what do? We now have whole numbers. They are of the same type. These are both whole numbers. They are both of the same type. So now we can simply find the highest common factor between 6 and 12, which I know you guys will tell me in the comment section what it is. The highest common factor is between 6 and 12. Yes, Remo. Okay. For this specific scenario, they've given us denominators that are the same. We'll look at that situation or that scenario. All right. In actual fact, I might not look at it today, but at a later session I will. Okay. So highest common factor is 6, right? Please, guys, we look for the biggest number that goes into both. So 6 divided by 6 is equal to 1, and then 12 divided by 6 is equal to 2. So therefore, our simplified ratio for 1 over 5 and 2 over 5 is equal to 1 is to 2. Okay. Simply put, remember people, highest common factor, like I said, I did a video lesson for highest common factor. I did a live session on highest common factor and lowest common multiple, and have uploaded that video onto my YouTube channel, Maths is a Game. You can find the link in the bio. If you're really struggling with finding highest common factor and lowest common multiple, you need to actually be well versed in finding those respective things, because they make the foundation very strong. Okay, very strong. Okay, and then the last example, which I will do for the purpose of this particular lesson where simplifying ratio is concerned, is the following: 0.72 is to 0.12. Sweet. What do you see? Okay, you see decimal numbers. You're welcome, Bambi. You're welcome. You see decimal numbers. And these types of decimal numbers, all right? Like I said, Roland, if you want to know all of that, the difference between HCF and LCM, they are already, these are lessons, live lessons I've done already. I think the last time we had a grade 9 session, I did that. You can check my YouTube channel. Go to my bio, you go there, you type, and you can send, okay? You can type there, you can actually click on the link. You see, now I'm being confused, I'm confusing my words. You can click on the link there, it will send you directly to the YouTube page. It's called Maths is a Game. The thumbnail for that video is written grade 9, highest common factor and lowest common multiple, and you can watch that. You can obviously just forget about the introductory things I say, because when I introduce the lesson and all of that, there's a few things I say, but get that out of the way and then you can proceed. Alright, so let's go. 0.72 is to 0.12. So what is this, guys? This is what we refer to as a ratio that has decimals. What type of decimal is this? So my learners who have been here with me since December will know that the type of decimal 0.72 and 0.12 is called a what? Let's check if people can still, especially those who've been here for the longest time. What type of decimal is this, guys? 0.72 and 0.12, we call them, very beautiful. Leseho, you can see Leseho has been here since the beginning. Yes, because we're busy in December. These are terminating decimals, and we call them rational numbers as a result, because they are terminating. All right, thank you. Now, first step, what do we do when we have a terminating decimal of this nature? I'm sure you can see that this decimal for 0.72, because whatever we do here, we have to do there. All right, please, I'm sure you guys are noting that whatever we are doing on one side of a particular ratio, if it has not reached its whole number state, we actually do the same thing on either side to ensure that does get to that. So 0.72, as you can see, is a decimal, and 0.12 is a decimal. So what we would do here is that we can see, in order to convert this to a whole number, we actually need to move the decimal how many times to the right? 2 times. Oh, and even this side, okay, we need to move the decimal how many times? 2 times. What does that actually mean when we move the decimal 2 times? It means we are multiplying both decimal numbers by what? by 100. So that's the step that we are doing here. Because what have we noted? We've noted that the two decimals, firstly, are not whole numbers. So if they are not whole numbers, we need to convert them so that they are whole numbers. So our conversion process for decimal numbers is we need to actually move the decimal for each respective decimal so that we achieve the whole number state. But for this, what do we do for both numbers? We times both numbers, decimal numbers, by 100, because that's how we get that to be decimal. So that means we have 72. The minute we times this by 100, we get 72. The minute we times that by 100, we get 12. Are you with me? Then, from there, these are both whole numbers. They both are of the same type or same quantity. So all we need to now do is find the highest common factor. So the highest common factor between 72 and 12, my good people, what is the highest common factor between 72 and 12? Anyone who can help me out? 72 and 12, what is the highest common factor? Let's say Ho says 12. This is grade 9, but also applicable to grade 8, of course. Let's say Ho says 12. Very quickly, Urula also says 12. Peladi says 12. Bontle says 12. Okay. Yeah, these are sharp minds. These are very sharp minds. The people who are responding, they're very sharp minds. Sivenati as well. 5 Majab also says 12. So yes, guys, it is 12. The highest number that goes into both numbers. So we do what? We divide by 12. Okay? And then what's 72 divided by 12? We get, I'm not gonna write it down. What do we get? What's 72 divided by 12? Oh, I see. 6 is 2. Very true, it's 6. And then 12 divided by 12, a number divided by itself. Okay, thank you so much. It's 1. So therefore, our final answer is 6 is to 1. Okay, thank you guys. Thank you guys. All right. So I will be uploading this onto the YouTube channel, alright? For those that may have missed certain things, maybe you feel like, so can you go and explain that thing? I'm going to upload this thing onto the YouTube channel, Maths is a Game. Then you can rewatch it, okay? Yes, here, I do. Just go to my bio. You'll find it there. It's also called the YouTube channel, Maths is a Game. You just go there, you click. And guys, the videos are not edited. They are as raw as you see me speak. I don't have time to edit, right? Unless someone is saying, I say, no, actually, no, I don't need that. I don't need to edit it. I want it raw like that because that needs to be my signature mark. I don't want any editing. So, yeah, you see this phone of mine move back and forth. You'll see the moving back and forth. You'll hear me say the things that I usually say just like that in that YouTube link. Sevenati, I'm holding math sessions with the grade 12s every night at 10:30. I held a session yesterday, all right? We are going according to the ATP. In fact, for all these sessions, we are going according to the maths ATP for each grade. But so far, it's grade 9, 10, 11, and 12. Grade 9, every time, 7 a.m. Grade 10, I'm going to stop this session now, and grade 10 is going to start immediately after I'm done with this session. Grade 11, 9 p.m. at night. This is pure maths. I'm not doing maths literacy. Unfortunately, 7 at. Grade 10, like I said, immediately after I'm done with this session, which I'm going to end right now. Grade 11 at 9 p.m. We had a session last night, beautiful session. We started quadratic equations, doing quadratic expression, finding the maximum and the minimum. We started with that. We did that yesterday. Okay, we've been busy, guys. December we were busy, Tina. I know you guys were celebrating, but we've been busy. Then we were celebrating like this. Then grade 12 at 10:30, like I said, in the evening. Okay. So thank you so much, guys. Grade 9, it was beautiful having you. Hopefully when you watch the video you'll see how I started and all of those things. I will try and upload it soonest, but it will take some time because obviously you know how TikTok is, but I will eventually upload the video. But thank you so much for those that joined. Thank you for the follows. I saw a lot of people following. I want to thank the one person that actually sent a rose earlier on as well. Thank you for that. Yeah, thank you guys. Thank you. I know people want other grades, but I need to get an indication, especially for grade 8, because I started one session with grade 8, but the reception was not as nice as I would have wanted it. So I basically put a hold on that. I'll be sending the the game challenge problems. All right, I will post the video onto the TikTok page as soon as I am done with the grade 10 session, so that you guys can have some follow-up work to do. All right, for those who are joining in for the first time, please guys, I will do that. All right, I'll see you guys tomorrow, 7 a.m. same time, 7 a.m. I know it's Sunday, all right, but I will run the session anyways, and then I will upload the video onto the YouTube channel. I know some people won't be able to join because of church and so forth, which is fine. Yeah, it's just that I go to church a bit later, so I can actually do that session. I'll do it in the morning for grade 9. I'm saying tomorrow, guys. Those people that I'm talking about, tomorrow is Sunday, isn't it? Or am I getting my mixed don? Today is Saturday, guys. Tomorrow is Sunday, I told you. And so, yeah, I'll be having a session as well tomorrow just to wrap up. Yeah. Thank you so much. I know, guys, it is early. You know what they say, the early bird catches the biggest maths levels. You see, so that's why we are doing this, especially for these grades, your grades, all right? Yeah. All right. Thank you so much. Yeah. Thank you so much. Thank you. Let me leave now. Thank you. I need to save this video, then I'll come back for grade 10 just shortly. I'm coming back for grade 10.